hear me? And I'll move this somewhere else. I have some pretty cool setup that I'm doing. Now the thing just disappeared. Okay, so the sound thingy disappeared. All right, so now we are on another level. I just don't understand why is it detaching? So now I have no idea what the sound is. Okay, there it is. The sound's back. Okay, this thing is back on. Okay, so can you all hear me? We got sounds everywhere. We got sound and sound systems and so on. Oh, that just disappears. It disappears when I click this. It just disappears. Why would it disappear? So now it's gone. So now anything I click disappears. Okay, this is just trash. Okay, so attach. I gotta attach that. And yeah, so now I gotta move this up maybe. Can I move this up? Okay, so anyways, can y'all hear me? Who's in the chat? 0 people can y'all hear me? Okay, I'll post there. I'll make it live here. I think it should be fine. Let me listen to the audio itself here. Let's see. Okay, so anyways, can y'all hear me? Okay, sounds good. Get Timothy Sullivan's in the house. Let's go, Tim. All right, we got Timothy Sullivan in the house, and I'll post this everywhere else. Can y'all hear me? And BitChute. Okay, you're audible, epic. And let me know how the audio is. Again, be extremely critical of my audio, especially audio, because audio is the absolute like killer. If you get it right, you can deal with even if the video is choppy as long as it's audio you can hear. Okay, Nebula Anas Bina Yaha. Let's go. Get pinned. Let's go. Epic name there. All right. So anyways, yeah. So I have to get a bunch of stuff sorted earlier in the morning as and basically had to reschedule my flight to John Hutchison's place. It's gonna be on the week after, so everything's moved over. And we'll go over LiDAR today and some other stuff and what other questions we had in there. And I have a metadata of just links to cover and so on. So I think I'll just click whatever's in order and then see what happens. But before we get to that, yeah. So again, some of you guys have seen my flat Earth debunking videos, and now it's like so one of the videos I actually made was debunking Eric Dubé. So I made it when Eric Dubé, again, he has like the most annoying voice probably of all time. So MES debunking flat Earth disinfo agents like Eric Dubé, so you don't have to. This guy commented, Dubé's voice is soul draining. Thanks for listening to him, so we don't have to. And I made a video about him. He's straight up just lying. I made a debunk about his debunk. So debunking flat Earth and Eric Dubé, a mountain's shadow below clouds is in reverse direction. So it's like he's literally straight up lying. If you've seen that, it's just straight up. Okay, we have Gonzo. Okay, Gonzo's in the Rumble one. Okay, we have he was the solo Rumble commenter. I can hear you. Okay, I just read the typo. LiDAR. Okay, yeah, LiDAR. We'll go over LiDAR. That's the light whatever 3. You can create 3D stuff with LiDAR. We'll do LiDAR soon. I just want to cover just quickly these things in the alt media news. So so here's a again, it's a really good debunk of flat Earth. So if you go to like mountains, or even tall buildings, when it's sunrise, yeah, when it's near sunrise, you can literally see like the shadow of, and if there's clouds nearby, like you can have the shadow of the actual mountain or the tall building on the cloud. So in other words, the sun is below the horizon. Okay, it's not going to be yeah. In order to do this, it needs to be below. All right. And then if you go above, if you're above the clouds there, you can see the shadow going downwards. But notice the difference here. When the sun's above the mountain, the shadow points into a point like that. They converge. But then when it's below here, it diverges. So shadow below clouds, shadow above clouds. And then Eric Dubé said that, oh, this one's actually from the shadow above the cloud, and he was just lying. Straight through, and then he also made some bunch of mumbo jokes. So anyways, so in that video I do a debunk of Eric Dubé's debunk of my earlier flat Earth debunk and show that the mountain shadow forms opposite triangle shapes depending on if it is on top or below. Anyway, so it's pretty straightforward. But anyways, going back into why I cover him is because recently, literally, again, he has 230,000 subscribers. He uploaded yesterday a 9/11 inside job. And he's posting the most bogus thermite nonsense of all time, and he's basically referencing Stephen E. Jones about thermite. Okay, so I'm getting a phone call. It's a spam. Anyways, yeah, so he's posting the bogus thermite. Okay, unbelievable. Went to spam. Okay, yeah, so he's posting this stuff. He's saying evidence of thermite or thermite used to cut the columns, right? see these perfectly cut columns, and notice it's all a cleanup crew, and also the cleanup crew is all there cutting, and this is actually probably a few weeks later. And what he doesn't show is that these are actually just they're cutting with thermatic lances or just oxy whatever hoses. So they're literally just cutting it. So he's saying that this is evidence of thermite or thermite used to cut the columns, but it's literally just the workers cutting them. You can see a whole bunch of workers cutting all these. There's one here cutting this one, cutting the steel. There's one on top here. This is probably an earlier one. So he's cutting up top there. Yeah, so it's like, yeah, or actually maybe a later one, because he's cutting higher up there. So it's like, how easy debunkable nonsense is it? So anyways, flat earther connoisseur Eric Dubé outs himself as a 9/11 disinfo agent by promoting the thermite / Stephen Jones disinfo nonsense, including including showing the cut steel columns, which are cut with thermite lances during the cleanup, or oxy, whatever. And again, it's just absolutely ridiculous. And also note the bottom there, Neo the home robot. Guess so we got robots taking over the game. All right. Anyways, Gonzo only Rumble one there. Again, you get prime real estate. So basically, anytime you comment, you pretty much get a shout out. So that's the benefit of being on Rumble there. All right. So that's pretty. Again, that's pretty wild. Okay. So we'll cover LiDAR soon. And yeah. So again, this is Eric Dubé is in there, and I have a giant list again. I'll open up my list. I think it's 99 passengers. Okay, so I emailed them, telling them, yeah, I saw your email in 9/11 Revisionist. That was absolutely amazing stuff. And the other thing, yeah, so I added Eric Dubé, Flat Earther. The Whitney Webb's in there. We got 56 people so far in this list. 56, and there's links to all their nonsense ones. Again, it's absolutely ridiculous. Ridiculous. The only one I didn't want to include was Charlie Sheen, because I'm like, I kind of feel like that's substance abuse. It's like basically abusing someone that's addicted to drugs. It's like the guy doesn't even know what day it is. All right. Anyways, yeah. So hello everyone. Tammy's in the show. Yeah. So epic stuff there. Yeah. So anyways, 56 people. Like think about this. Like how much these people every day, and I included this one right here. Really graceful. But the thing is, because she doesn't really gatekeep 9/11, but the thing she knows by 9/11, she's actually liked some of my tweets and retweeted some of my stuff, but just avoids discussing it. So I put in there just because she's avoiding it, but has decent info on other topics. But again, you gotta, if you have a big channel, you have to talk by 9/11. It's so obvious and so easy to just it's just the big one. It's like the biggest psyop ever. But then instead they're like, hey, there's another little tiny psyop here. Yeah, but who cares? The big giant one means whatever. And also, 9/11 Revisionist, since you're here, so Alan Forrest gave me these 2 copies right here. Do you have a copy? Because I could mail one to you in South Africa. 9/11. Do you have a copy of this Truthers? And the thing is, this one right here, but they also include a Stephen Colbert or what? No, I mean. What is his name? James Corbett article too, which is a bit wild. So again, they put everything in there. But great that they had that they included this Grok conversation with 9/11 Revisionist, basically reviewing all his articles and so on. And I took photos of the entire article. So 9/11 evidence discussion with Grok AI. What did Grok have to say about after reading my 123 Substack articles to date? Yeah, so by 9/11 Revisionist, on Wednesday evening, 26 March 2025, till early, anyways, I was in conversation with X's Grok AI, and the instruction was to given to read through all my 123 Substack articles and come back with a summary after cross-referencing all my statements with the official NIST report, the 9/11 Commission, all the narratives put forth by 9/11 Truth Movement pertaining to what happened on 9/11. It went remarkably better than my first attempt a couple months ago, where Grok just ended up giving me a silent treatment. LOL. Okay, epic LOL in there. Okay, today is the 3-eye atlas is said to reach perithylene. Some say will have dramatic impact on Earth. Yeah, I was gonna cover that, but again, I've known you with it just feels like it's like different language, like 3-AI atlas. I'm like, what or 3-eye atlas? I'm like, what is going on here? Okay. Another just said Drew 375 copies. Yeah, epic stuff. Okay, great stuff. Because I told Alan, give me a copy. I'll give it to send it to you. So you already have one. So I'll just keep these 2. And so on. Anyways, so he wrote this over there, and it's pretty wild. Yeah, and again, it's like the beams, the memorial of the blue beams there, absolutely again ridiculous. Okay, and then so Gonzo, Druther's epic stuff there. Yeah, avoidance is a form of ignorance. Yeah, truth is pretty epic. It's like you go read mainstream news, and then you read that one. It's like you're all getting depopulated. I'm like, all right, let's go, and so on. Dubé is a slang term that refers to an individual who is perceived as pretentious, arrogant, and fake. The term originated in the 2000s, has been since widespread used among young people. Interesting. Dubé. In the early 2000s, probably when he came out. Ken Wheeler on 3i Atlas. Yeah, we got Ken Wheeler talking about that. Okay, Ken Wheeler's Weldon. Okay, well, how does he get so much views? It's like he just talks about 3i Atlas explain other sciences. 30 Theory hypothesis. 13,000 views. Unbelievable, 15 hours ago. So again, and it's just him on the screen just talking. I do like his he's very like he's like a wordsmith, but again, it's like he repeats the same thing over and over and over again. I don't know how he gets so many views, but he was pretty cool. Has some interesting stuff, but again, we have to get on the same page. I do learn geology, not in maths. By the way, okay, is this yeah, Nabila? Yeah, we'll go over LiDAR soon. Look at the tiny blue beam at the right side of the image. Oh, this one right here. This blue beam. Yeah. Yeah. So, anyways, that was that one. The blue beam. There's another blue beam there. But anyways, this is directed energy weapons, a new tier of electronic warfare. Yeah. So it's again, we're on another level. He's pompous. Yeah, I know he is pompous, but his word salad game is pretty epic. Because you can tell he's got some sort of ability to speak. But kind of lose tracks of where it's going. But also, he has a pretty sad story about his wife. His wife had cancer and was like dying slowly while he was like having to take care of her. So, anyways, so he's got stuff there. And Ken Wheeler has a Substack now. Okay, so Ken Wheeler has a Substack. Yeah, Substack is great for the email sharing and so on. But again, don't just think that just because it's getting big and then it won't just remove your stuff because it can and will. Quantum, yes, getting some quantum stuff. Okay, he's already writing articles now. But again, it's like half the time when you're listening to him, it's trying to decipher what in the world he's talking about. It's like, okay. Yeah, that's kind of what I mean. Pan's on the thing. Yeah. So he's good at putting philosophy and so on. And like strict definition terms inside that. But again, practical stuff. We need to get free energy stuff. You can't be a free energy guy and then act pompous when you don't have an actual device. So here at MES, if I get a free energy device, I'll be super pompous. Actually, just joking. I can't be. It's very hard for MES. Okay, what if you're targeted? Okay, targeted individuals. Okay, I was gonna post this one here. This is a billionaires. We started from nothing in our garage. The garage is this Illuminati all over your body, and quite surprising how much billionaires started from off their Illuminati garage. So here's a comprehensive table of notable billionaires as of late 2025 who embodied racks, the richest story. So Jeff Bezos, 240 billion. Garage starter. Larry Page, garage starter. Google. Yeah, Larry and Sergey, whatever. Garage starter. Mark Zuckerberg, college dropout in his dorm. He created Larry Ellison, college dropout. Bill Gates, college dropout. Michael Dell, college dropout. This guy here, no college, but and poverty. What's up, founder? Again, if you believe this, Oprah Winfrey, poverty. Okay, it keeps going on. John DePaul. This is another thingy. Twice homeless. Okay. Worldwide technology. Anyways, segregated poverty. These are all just yeah. GoDaddy was also poverty as well. Okay. Anyways, just can't make this stuff up. Okay, he's pumped. That did not know. Clever, sad. For sure. Yeah. He says that a couple times in his thing. You could even go to Okay. Yeah. So again, for those who are new here, the first few minutes is just me going all over the place until I settle down my mind. What is this? Ken Wheeler. Yeah, and forever I pick for okay, Theoria. Okay, it's like how do you like what kind of name? It's like even his name is pompous. It's like just pick it, Theoria Apotheosis. Yeah, just call it like philosophy theory or something. Something some lowly peasants can know. So you can see here cancer wife. Probably okay, it doesn't have that cancer. Whoops. I think he mentioned it before, wife. But also, again, he's got the double chin. He's got get rid of that double chin, please. I think he mentioned it before. Don't watch this video. Might be on one of these. Wife. Manufacturing safety, unhinged world. Don't watch this. It's 4 years ago. Maybe it was in this one. And also we'll do just random quickly stuff here. Then we'll get into the nitty gritty. I just wanna again Cancer doesn't show it. Wife. Okay. Anyways, he said it was pretty grueling. The other thing I want to show is, because it's Bitcoin address. Let's see how much Bitcoin he has. So he has Bitcoin address donations. Let's go to Bitcoin Explorer, Blockchain Explorer. Okay. We'll go to Bitcoin quickly. See how much he's earned. Again, that's a cool thing about open source. Okay, there's the address. So he has right now it's $232. So he had $43 donation before. So total received, he total received 0.39 Bitcoin, and then total sent for 0.39. So the total sent was $43,000. Yeah, $43,000 of Bitcoin. That is what's the chart of the actual price? And then he would withdraw it. So I would assume he'd cash out. And then total, yeah. So you could see this is when the price is going up. So if you just held, probably it would have been. Yeah, but yeah, he probably cashed out a lot. Yeah, it's 43,000 if he just held, but he probably had yeah. So let's just minus. We probably had like $10,000 of donations in Bitcoin. So again, that's pretty cool stuff there. Yeah. So anyways, you can just check stuff out because he probably was selling and so on. Okay, he's an utter scumbag Dubai. He knows the planet is a globe, but the Pentagon gave him the job of pushing NASA's PPP pancake planet side. Okay, let's go PPP. I thought you were gonna say protective gear or something. Okay, anyways, so we got that. Okay, and then what else is happening currently? I think. Oh yeah. The other thing is yeah. Okay, so he has five of those. Yeah, because I was actually gonna send it to you, but then I realized you actually have one. 9/11 Revisionist has 5 copies. So there's your Truthers book there. But I would have James Corbett in there. If you added names in there, that'd been pretty cool. Okay. Okay, and now. And also apparently Iran has a lithium gold mine. So again, you wonder why it's getting bombed. Okay. Anyways, another thing is Jamaica. Okay, this thing I was sent here, and I'll cover it today. So this guy sent me. This is Jamaica's being erased right now. Hurricane Melissa slams into Jamaica as the most powerful storm ever. No way, Hurricane Melissa. Okay, Hurricane Melissa's wilding. Okay, let's see this setup here. Okay, and also let me know how the audio is and so on. Okay. Let's go Hurricane Melissa Wiki, and I was gonna say Grokpedia, but Grokpedia is just the same trash. Okay, Hurricane Melissa is currently a strong Atlantic hurricane exiting Cuba, the 13th named storm, and where does it say strongest ever record? Okay, this is, oh no, Hurricane Melissa made landfall on New Hope, Westmoreland as a Category 5 hurricane in the strongest landfall Jamaica has ever recorded, surpassing Hurricane Gilbert, which made landfall in eastern Jamaica as a low-end Category 4. So this is 1988, when I was born. Okay, so we got that. Hit Jamaica as the strongest landfalling Atlantic hurricane ever. Okay, so we got literally a hurricane destroying everything. Let's see what's actually happening in Jamaica. Okay, let's see, Brush Junkie. Is this Rebel News or something? Where's she from?
20 UTC. That's the last we see. Then it cuts out, and then it skips. You can theorize if you were to put your tinfoil hat on, what they wouldn't want you seeing them.
Maybe Frankenstorm. Jamaicans take precautions anyways. So apparently it goes over a bunch of stuff. I'm gonna just summarize this. I'll watch later. Let me know what it says. Again, 20-minute video. Just tell me, like, a lot of times people send me videos and so on, but it's like, what I want people to do is, it's like, they watch and give me the most, like, bombshell info from it. It's kind of like similar to, like, Where Towers Go, like Dr. Judy Wood's work and so on. It's like, you can still summarize everything she's ever done with, like, the most important stuff, and she even does it herself. And I'll give you well, whoops, I'll do the summary after. I'll keep it open like this. MES links, open this one here. And now, yeah, so I'll keep it like that. So what I mean is, yeah, I'll do a, now I'm just setting up some stuff. I'm gonna go summarize and see what it says here. Yeah, summarize this. Agenda 30 wants to create smart cities in Jamaica. Weather, warfare, land grab. Yeah, definitely. But the thing is that they're doing smart cities everywhere. Like here, even a hurricane comes here, they probably will. And yeah, speaking about that, it's literally so this is actually quite wild. I didn't realize this. So I knew that the Canadian government was stealing people's land and then giving it to the natives, but then it's probably United Nations owned, etc. So British Columbia Supreme Court awarded the Kawicha tribes an Aboriginal title over roughly 800 acres of land in the city of Richmond, a suburb of Vancouver. So this is where I live. So homeowners in Pacific Northwest City are warned their land has now been given to a native tribe, and that eviction could soon follow. And yesterday there was like 100 of the people affected, 100 homeowners. They were at a meeting at near the airport hotel, and that's where I went over there to Richmond City Hall because and Alan Forrest was protesting. So it's like, see this land grab. This is all the land that they're taking. And my house is like literally 5 minutes away, right here, where my mouse is. It's like there and there. I'm like, what? And there's the please take note the recent BC Supreme Court decision. Anyways, this is what they give to owners. And then basically, and now I'm identifying as a native of the Chief Nakata tribe to prevent the Canadian government from stealing my house. Okay, so there's me. So if anybody asks, I am a native, true and true. All right. So anyways, we're taking over the game. Yeah. So it's a category 5. I'm gonna see. I'm gonna go to Jamaica. I'm gonna go see what there's happening in Jamaica. How do you spell it? How do you even spell Jamaica? My goodness. Okay, Jamaica. Is there even a Jamaica? This entire thing doesn't have Jamaica. Oh, there's an A. Okay, AI. Okay, Jamaica. Let's see any local footage. What's happening to them? Okay, hurricane. Witness the raw power of nature of a U.S. Air Force pilot navigates through the eye of the hurricane. So it's flying in the eye of it. Okay. Okay, so we actually got this thing flying through it. Okay, so the question is, what is a U.S. Air Force pilot doing inside the hurricane? Okay, so they're definitely doing some next level ish. Okay, so we got this. Okay, we got some birds in there. So we got some giant hurricane. Let's see what's happening in Jamaica. Only John knows if Jamaica will survive this. Okay, this is 5 hours ago. 53 inches of rain in 10 hours. Okay, this house is... oh, this roof is gone. Okay, the roof is gone. My goodness. How else do you think they steer and control hurricanes? Yeah, that's a good question. But again, it's like 9/11 shows they got technology that's not public. So it's like even when they say direct energy weapons in the public sphere, they're just talking about lasers and so on. It's like what they should be saying. Hudson effect, giant. Okay, Jamaica, 2030 Jamaica. This is visit Jamaica, a paradigm shift to prioritize the higher forms of capital, human knowledge, culture. Okay, and then there's a hurricane. Who made this logo there? Is this a real image? No, is this added there? I think it's added. It can't be there. Vision 2030 America. Okay, so Vision Jamaica. Okay, and then we'll get back into the Mystic Bazaar's in the show. Okay, epic stuff. I was gonna go over some of your messages soon, and then we'll go over the LiDAR and so on and everything else. Let's see what the actual thing says. But is there a hurricane? Where's the hurricane? I think the person just photoshopped it in, which is probably, but I just want to see, like, somebody to give me a hurricane thing. Okay, so anyways, Vision 2030 America. But the thing is, everything is 2030 happening, so they're definitely going to be destroying everything to remake this. Is this, which page is that? It's like, I hate it, and I'll just put a link there. Just put a link. Like, what's the point of this? This is kind of what I mean, like, you need to be able to find links and so on. Anyways, let's see what the summary says here. Hopefully it's still working. Okay, so refresh this live update. Okay, there's a summary. So this summarizes it. All this. So analyzing Hurricane Melissa and emergence of smart cities agenda. Okay, so it says that dwell in the alarming developments surrounding hurricane recently. Recent geoengineering activity and the strategic move towards establishing smart cities in Jamaica, particularly in Kingston. The conversation offers a comprehensive look into the potential manipulation of weather patterns, technological infrastructure, and geopolitical motives behind these developments. Additionally, they provide updates on their geopolitical issues, including a dispute over a gold mine in Alaska and the broader implication. Okay, so we got the whole summary in there, and it's all going on the Hive blockchain forever. This detailed exploration reveals interconnected motives, environmental control, urban surveillance, resource extraction, and geopolitical strategy embedded within manipulation of natural systems. While some have dismissed these ideas as conspiracy theories, the accumulation of evidence and patterns discussed by Derwin and Buell underscored a need for vigilance and understanding how technological and political agendas may reshape our environment and societies in the coming years. A lot of people South Florida claiming there's no hurricane as not being affected by the weather, but they should be if there is one in the vicinity. There will also be an earthquake in the subduction zone. Interesting. Gary Jackson, good luck with your new ancestor. Okay, thank you. Thank you. I am born and true native now. I am part of the Chief Nakata. And yeah, so basically I can go to my neighbor and be like, hey, I'm native. You have to give me the rights to your house now. I own it. Taking over the game. All right, whatever it takes, guys. Whatever it takes. All right, anyways, so that was this one. Most powerful hurricane there. Okay, so we'll keep that. I just want to see if there's any more footage of houses getting. Okay, this is one of the some houses roofs getting taken off. See some cars. It would be cool. Yeah, and the levitation of cars. People realize even if it's a lot of strong wind, it's like to levitate like a multi-ton car. It's not easy. Okay. Okay, so that's that. This 16 hours ago. Roof off 4 major hospitals flooding wards. Okay. Is the city underneath the hurricane image? The city in which it hit shore. No, but that image. I'm saying, where is that image? I have no idea, but it might be probably the same place. You have to double check that. I don't have time for that. Okay. Anyways, so hurricane is wild and. Okay, that was the same roof there. I'll share this one. I'll share this here. Oh, okay, this is microblog. This thing is it's a bit down recently. I don't know why. Okay, latest. I think I posted. Okay, nothing's updating on this right here. Let's go back to my threads. Okay. Yeah. Anyways, I'll be posting there on these live streams and then this hurricane. Okay, so we got that and that. And next setup is see what else we had. Okay, LiDAR. Okay, we'll go over LiDAR quickly. Or just for a bit. Yeah, LiDAR here. Anyways, so LiDAR, and then we'll come back to it later, is an acronym of light detection and ranging, or laser imaging detection and ranging. So basically, he's literally using lasers to fire down, and then the reflection. What happens is you'll time it. So let's say if you shoot it down a giant like empty hole, it's gonna take longer and then reach back longer. So then all you do is time the difference in time, and then correlate that with the speed of light, and then you can measure how far something is. So from there you can actually plot the contours. So it's a method of determining ranges by targeting. Ranges is distance, basically distance by targeting an object or surface with a laser and measuring the time for the reflected light to return to the receiver. LiDAR may operate in a fixed direction, vertical, or it may scan multiple directions. So the vertical one is the one that's the 9/11 one that was done with LiDAR data. So you can see LiDAR right here. So it literally just shines lasers down to the... And that's a pretty fitting thingy here too. So this was printed from LiDAR data. But again, and it's pretty interesting. So LiDAR literally has like a plane flying over, and then literally shooting lasers from space. No, lasers from a plane down and up. So it's like pretty fitting. You got laser beams. Okay, LiDAR. Where's the original LiDAR? So here's the original LiDAR, and this is Judy Wood one. And this might not be the scale. I need to double check what the actual size is, because Judy told me that she just put a just a rough guess at how high it would be. Because it just shows it's tiny. People survived here. It might be even higher. They might even go above the screen. Yeah, it actually might go above the screen. So what I'll do quickly is I'll move this to the side. So let's go like here. Yeah. So I'm gonna. Oh, whoops, not that. Snap it. Whoops. It's like just nothing's working. Copy does not work. Okay, it does not work. I'll just go back here. 10i. Okay, it's actually ridiculous. Like, how am I supposed to... Like, I hate this is the one thing about Macs. Everything's got you need permissions for everything, and it's like that one doesn't do it. Some don't, some do. Like, just work. Okay, I'll just do it like this right here. And this was taken again, I think a week or two after 9/11. But again, not much rubble was removed because it's impossible to remove that much. Okay, so this is there. Just want to see the height here. And then compare that with, and then the other one I actually measured, it is to scale, the one I have. So now we have LiDAR, 3D printed models. Will be like this, but this one I think I made this stretched. Oh, no, this should be exactly, or it might be stretched out, is it? No, 1, 2. No, it is about the same size. So the question is, how high is that other spot? And I'll do that here. I'll just watch the video. Go watch the video quickly. Go and I made this one here, and what I'll do is, yeah, and we could do a split screen too. Okay, that's cool. Okay, so we have this. So here's the actual, like pretty much the scale. Okay, so that's the scale with the actual models. Okay, and then hide this. It's still showing there. That's interesting. Used to not do that. That's not supposed to show that. Okay, so that doesn't. Why does it do that? Oh, it's playing. Why is it playing? Okay, just like, okay, there it is. That's how you hide. Okay, now it does that. So what I'll do is do this. I just want to see the exact measurements difference, and now we'll do another snippet. Okay, and now we'll do split screen here, and then open and split screen, open and split screen. Where's the open button? It's like add tab to new split view. Okay, just do it. Okay, there it is. So now we'll see how accurate is it. Okay, so this is that's over there, and this is actually rotated. WTC6 would be this. This is a bit bigger, and this is a bit smaller. Okay, this is a bit hard to tell. It should be, yeah, it should be roughly the same. Okay, it's roughly good enough. It's good enough. Anyways, I just need to input my readers on. LiDAR is made possible through chaff residue impeded in all plants and solids. The more impeding, the better the imaging. Into chaff residue. What in the world? Talking English or what language are we talking? Anyways, what's the chaff? So there's no mention of chaff in Wiki, so I don't know what you. Your LiDAR has terrestrial and also laser scanning. Okay, LiDAR may be operating in a fixed direction, or it may scan multiple directions in a special combination of 3D scanning and laser scanning. There. LiDAR has terrestrial, airborne, and mobile applications that is commonly used to make high-resolution maps, with applications in that and so on. Here's a laser-derived imaging of marching bears mound group. What in the world is marching bears mound group? These are actual bears. Marching LiDAR image of marching bears mound group. Like, do people not speak English? The marching bears mound group in high definition. So these are actual bears. Those are actual bears getting hit by laser beams. Frequency addition source of optical radiation. If it uses a Starfire optical range for LiDAR and laser guide star experiments, is to the sodium D2A line. I think that's like a frequency from yeah, and used to excite sodium atoms in the upper atmosphere. So you can where it's used to excite sodium atoms in the upper atmosphere. So you got this giant laser exciting sodium atoms and so on. Okay, we got laser beams. This little LiDAR may be used to scan buildings, rock formations, etc. And then distance. It basically goes like this. Here's the input, and then there's the receiver. It could be even the same thing, but this input, and then, yeah, the receiver is the bottom one. Diagram is illustrating the concept of time. Diagram is required because if it's flying over, and then you have to measure how much time it's flying as well. And basically, if you have this, you can measure the distance because you know the speed of light. So all you need to know is time. And speed of light times time divided by 2 is the total distance back and forth, and so on. And then yeah, and then this there's a difference. Oh, and there's a time across from. No, oh, this is time. But never mind. So basically, it shoots there and back. But this is time. This is including time graph. So you have this, but basically it shoots forward and back, and then this is with time. So let's see what this says. Yeah, so here's the plot. A basic LiDAR system involved a laser rangefinder reflected by a mirror top. So basically, laser goes to the mirror. So it's always this, and then it's spinning there. So you have the laser firing straight, laser, and then this one is directing. This is giving a 360 span. So 360. Once it hits this, the time to come back is quicker. So you now have an object over there. So you can measure the distance. So basically, you have this calculation. and then you plot all the points, how long it takes, and then you could plot that so that this ball is over here, hit by the laser. And then you have a drone too, LiDAR scanning performed with a multi-copter UAV. Yeah, that's amazing. Airborne LiDAR bathymetric technology, high-resolution multi-beam LiDAR, a map showing specular, faulted, and deformed sea floor geology. This is shooting into the sea, so you can pass water. This mobile robot uses its LiDAR to construct a map and avoid obstacles. So now you got LiDAR. Again, you gotta have it in cars and Teslas and so on. And now we got this one here, a robot shooting around and then basically shooting at people and finding out where everything is. LiDAR, okay, this one here, LiDAR uses to analyze yield rates on agriculture fields. Okay, so this one is actually LiDAR on agriculture. So it's using for everything. So you can see how much is growing higher, taller, shorter. If you're flying LiDAR around your neighborhood using Telenet optic Zemel, you have a much bigger problems. Check out the negative effects on grok. Interesting. Okay, so if you're firing people laser, okay, this is make it. Why did it get smaller for some reason? Make it bigger like that. Anyways, I have no idea why this shrunk. Okay. Chaff creates a large cloud chaff corridor of false targets that can hide in our aircraft from. Okay, chaff corridor. Interesting. Anyways, we're on a tangent. So, a LiDAR-based spatial intelligence system tracking individual passengers in real time at passport control. So that's passport control. Okay, so now we got LiDAR in the airport, and this is LiDAR shooting at people. So you go walk into a airport and you're getting shot by lasers everywhere. A LiDAR of Roman fort in England. Okay, this is a fort in England. That's pretty good. And there's a cruise automation self-driving car with 5 Velodyne LiDAR units. Okay, Velodyne LiDAR. Using Teledyne. Oh, this Teledyne is Velodyne. Okay, this is it's got LiDAR everywhere. So imagine this is literally going around everywhere and shooting lasers at people. Forecast 3D laser system using a SICK LMC LiDAR sensor. Okay, so this is this sensor. LiDAR imaging comparing old growth forest right to a new plantation of trees. So there's old growth trees. You have trees growth too. LiDAR point clouds, classified point clouds. DEM normalized. Okay, we got some LiDAR detected trees. You can actually detect tree analysis there. Okay, biomass. Near range LiDAR at Institute of Geophysics. We got LiDAR shooting everywhere. Somehow like this. Is it closed off? Okay, it's shooting there. How does it bounce off everything? My brother worked for Teledyne many years in the 1890s. Interesting. This TomTom mapping van is fitted with 5 LiDAR sensors on its roof rack. So it's got 5 of these. So basically, like, you have the laser, the mirror, or whatever, and look at that. That's unbelievable. So, a point cloud generated from a moving car using a single ouster OS1 LiDAR. So a single ouster made this whole setup here. And LiDAR on a 4th generation iPad Pro. Okay, so we got a LiDAR scanner. A LiDAR scanner on an iPad Pro. Okay, and yeah, this is okay, we got phones with LiDAR. Alright, so now we're going to go, this was Action Lab that actually had this. Action Lab. Okay. Again, he's a gatekeeper, but you got to do what you got to do. Action Lab. But he does have cool videos. Okay, LiDAR. Yeah, and he has one with the how LiDAR works, measuring light speed with the first and best floor washing robot vacuum. Okay, and yes, I seen this a year ago.
This video was,
and I don't want to get copyright. I'll just get to the nitty gritty. Okay, this is this has a LiDAR on here, but he also shows it with a phone. With the phone is absolutely amazing. Oh no, I think that's 3D, but it's similar. Anyways, here's a LiDAR measuring light speed with the first and best floor washing robot vacuum. So you got a robot vacuum with LiDAR built in. See what it does.
how does that work? How does a tiny robot vacuum just look at a room and create a 2D and even a 3D image of the room? Today we're diving into
and notice the checkered floor there on the ground. Okay, we got the Freemasonic
room. There. Today we're diving into the incredible technology behind this robot to explore how these devices we've welcomed into our homes actually work. Now I want to test how clean this robot actually makes the floor after mopping. Okay. Since we can't
he's gonna spill water on it, then he's gonna get the robot to clean it. But anyways, there's some food as well. He eats on it. And it basically uses water because it does cleaning.
I kind of like this. I don't even have to clean a plate after. So I currently have my vacuum sweeping and mopping my room. Right now it uses 3
Okay, so it's a LiDAR. Okay, it uses 3 different stuff.
Different technologies to know what this room looks like. It's using time-of-flight LiDAR, binocular infrared imaging, and also visible light cameras. So if we look at the robot through this infrared camera, you'll notice something. There's a laser light that's only visible with this infrared camera. You can see it flashing and shining off the walls. This is an infrared laser.
Okay, 1 second. I'm just gonna adjust where this goes. Okay, now it's gone. Okay, I was trying to adjust my thingy here. Now I lost the thingy there. Okay, so now it's gone. Webcam 2. Properties. Where's the thingy? How do I show anything? It's this view, source. Where's the studio? Multi-view. Okay, now I lost the sound thingy. Edit source, advanced, sound collection, sound. Okay. I don't understand how this works. Okay, plus something. I just want to get the thingy. Audio input. No, I just. So I lost the thingy here. Remove, detach. Oh no, that detach. Okay, anyways, now we're lost. Okay, this is back. Okay, this is back here. Sources. Okay, attach. Yeah, this is I don't understand why it's so unintuitive. Attach. Now I lost the sound thingy, so I have no idea where the sound is. Properties. Okay, anyways, let me know how the audio is. I'll fix this up later. I just absolutely hate when things aren't obvious. Like, where is the sound? Wait, it's gotta be somewhere in here. Edit source, view, studio mode, reset UI. Reset UI. Is that how it is? Reset UI? We'll hide additional docs. You will need to unhide these docs if you want them visible. Are you sure you want to reset UI? Okay, let's see. Hopefully nothing changes. Reset. Okay, there it is. There it is. That's a reset UI. Okay, there it is. Audio mixer. But now it's just so tiny. Like, I don't get it. I don't understand. Like, I just want to be able to see them all. Okay, hide. Okay, I'll hide them. Oh, there it is. I can hide those ones. Okay, I think we got it. Anyways, I was able to hide that. Okay, anyways, I think it's pretty decent now. Okay, I hit. Anyways, we're back on. We're back in. And again, let me know in the chat what I should. Oh, whoops. This is just weird. Okay. Yeah, we're back in. Let's play this.
They use infrared lasers because at this brightness it won't harm your eyes. And
okay, so using infrared lasers, so it doesn't harm your eyes, apparently.
Also, there's no interference from the visible lights in the room. What we're seeing here is the laser light used for the time of flight.
Yeah, so notice here, this is using infrared like that. So that's actually infrared. It's pretty cool. So infrared, infrared camera, so you can see the infrared light there.
Time of flight LiDAR, binocular infrared imaging, and also visible light cameras. So if we look at the robot through this infrared camera, you'll notice something. There's a laser light that's only visible with this infrared camera.
Yeah, so there's an infrared right there. That's pretty amazing.
You can see it flashing and shining off the walls. This is an infrared laser. They use infrared lasers because at this brightness it won't harm your eyes, and also there's no interference from the visible lights in the room. What we're seeing here is the laser light used for the time of flight LiDAR. What it's actually doing is sending out very short pulses of infrared light, then timing how long it takes for a reflection of light then to hit the sensor of the robot. It's literally clocking the speed of light. But how is that even possible? The speed of light is 300,000 kilometers per second.
That's a good question, yeah. So how does it time it so quickly? And this is a pretty interesting thing it says right here.
That means it takes only 3.3 nanoseconds to bounce off and come back from something half a meter away. In order to measure that with any good resolution, first you'd need a clock that ticks much faster than billions of times per second. But the fastest computer chips have a clock speed of a few billion cycles per second. So that's not fast enough to measure this kind of speed. So how do you measure an event when you don't have a clock that can tick fast enough? Well,
yeah, I remember watching it again. Now I remember, yeah. So this is actually quite amazing. So basically, the speed of light is so fast that you can't even have a regular clock stop and go. So you need to do another setup where the light itself triggers the clock.
You have to be pretty clever. For example, let's say that I'm sending out a pulse of light like this. I'll graph it with this dark red line here. This is my light signal. So I turn it on and then off as fast as I can, and then I wait a bit and then turn it on and off again. So the speed that I can turn it on and off is fixed. Then I have a detector with a light sensor that gives a current when it sees the reflection. So I'll show the signal of the light detector with this red line. If we let them both run together, you can see that there's a slight delay between the signal and the reflection. So we want to know how much it's delayed, but the problem is we don't have anything that can tick or switch faster than the width of the light signal. So what we do is we have another switch that I'll call G1. It's this purple line. We'll turn this switch on when we have our light signal on like this. Then we connect it to a capacitor along with the signal from the reflection, so that when the G1 switch is on and we're detecting reflected light, then it'll charge a capacitor that I'll call S1. So whenever the purple line and the red line are on together, the orange line will increase.
Okay, so when these are on together, this will increase. So you have a capacitor basically when this is the reflected light, and this is the switch right here. So this switch is whenever this is on, there's a second one that turns on as well. And now whenever these, and then there's a reflected light. When these are on, the capacitor increases. Let's play this.
Then we have another switch that I'll call G2. This switch turns on when G1 turns off, and it lasts for the same duration as our light pulses.
Okay, so we have a G1 switch that turns on when this is on, and then it turns off when this is off.
Well, and we increase.
I gotta wrap my head around. This is actually quite I tried to wrap my head around before. I didn't have much time to look at it, but this is pretty cool. So time of flight LiDAR, and also I need to go quickly here, and we'll show these as well. I'm gonna paste these into this. This is pretty cool. Okay, paste this LiDAR. Let's go back here. Okay, so I want to go back to the beginning of this one. I want to wrap my head around, and then write it. Just try to wrap my head around. Okay, so you basically light is so fast that you can't have a switch that's fast enough. It just you can't just be like, I'm gonna use a stopwatch. Ready, go, and then stop. You can't have a time like that because light will be already there and back in like a billionth of a second. All right, let's go back.
A pulse of fast enough? Well, you have to be pretty clever. For example, let's say that I'm sending out a pulse of light like this. I'll graph it with this dark red line here. This is my light signal. So I turn it on and then off as fast as I can, and then I wait a bit and then turn it on and off again. So the speed that I can turn it on and off is fixed. Then I have a detector with a light.
Yeah, so that was on and off. Okay, now there's a detector that reflects once the light hits it, it reflects it.
Light sensor that gives a current when it sees the reflection.
Okay, so now there's, yeah, so basically you have the switch here, and there's the reflection. But the reflection is there's delay when you click the switch, and then there's a delay of time before it hits this. And this is going to be really rapid once the light goes past and hits it.
So I'll show the signal of the light detector with this red line. If we let them both run together, you can see that there's a slight delay between the signal and the reflection. So we want to know how much it's delayed, but the problem is we don't have anything that can tick or switch.
Yeah, and this is the reflected. Oh yeah, I mean this is the reflected light when it goes and it comes back. Okay, so you have a detector, and that's going back here. I think we have that image here. Yeah. So this is the light going this way and then going back and then hits a detector. Okay. So a detector's a slight delay in time, but it's less than the actual switch time because it's super fast. Okay, so it's super fast. So this is a reflected come back to you. And now what you want to do is measure this delay time. That's the key, is to measure this. That's our time. That is this time. The T. Then you can add it to your measurement and so on. Let's see how this is measured.
Switch faster than the width of the light signal. So what we do...
Yeah, but the thing is, this difference is less than the actual light on and off time.
Is we have another switch that I'll call G1. It's this purple line. We'll turn this switch on when we have our light signal on, like this. Then we connect it to a capacitor along with the signal from the reflection, so that when the...
Okay, so now it's basically now they have this one and adds to a capacitor with the reflection. So this one, a capacitor, and then it builds up each time.
So that when the G1 switch is on and we're detecting reflected light, then it'll charge a capacitor that I'll... Okay,
so this a capacitor charge. So this from here to here is charging basically from this point to this point is a difference between... is basically the difference between this signal, reflected one, and the off signal there.
I'll call S1. So whenever the purple line and the red line are on together, the orange line will increase. Then we have another switch that I'll call G2. This switch turns on when G1 turns off, and it lasts for the same duration as our light pulse as well.
Okay, so now this one is when it's off, it just lasts as long as the light pulse. Okay, so now this is, it doesn't go off the whole time, it just goes as long as however this light pulse was. And that's when it goes off. That's right when this goes off, it builds up, and so on.
And we connect it to a different capacitor that I'll call S2. So the S2 only charges when we're detecting reflected light and G2 is on. So you can see...
Okay, so this is when it's detecting light. Okay, yeah, so it's connected to capacitor with the reflected light, and when this is off for one pulse. Yeah, basically that one pulse is the reflected light. So we have two capacitors. One is when this is on, and then the other one is when this is off. Oh, I mean, the second switch is when this turns off, and the reflected light is on. Yeah, basically it's connected to it, and it just charges up.
See that the yellow line only increases when the red line is on and the pink line is on. And each time a pulse happens, only a tiny bit of light is collected in each sensor. So this is done thousands of times. And then the current from each capacitor is collected, and we just compare the amount from S1 and S2. And then you can use the speed of light to end up calculating the distance to the object that the reflected light bounced off of using this equation here.
Okay, so now they got a random other equation.
This is amazing that we can figure out the time it takes for light to reflect using time.
But where's the, oh, and this is speed of light, this is S1, S2. Oh, and that's the difference between here. What does he do here? S1 plus S2. What is the S1? Yeah, oh, that's capacitor, so basically you have a capacitor there. Yeah, basically it's using the actual capacitor to calculate the distance, or the time. Yeah, distance and time, basically same thing. Okay, so, and it's using some random calculation with the capacitors. Basically, when this is on, I mean, when the reflected light is being reflected, and this is on, it charges S1. And then when this is off, and this one is on, then that gets reflected. So notice it's a bit shorter. And so basically look at the difference there, yeah. So, and this would go on after it's already off, and the reflected light is on, and it goes up and it stops right here.
Capacitor is collected, and we just compare the amount from S1 and S2. And then you can use the speed of light to end up calculating the distance to the object that the reflected light bounced off of using this equation here.
Okay, so so basically it uses the capacitor current or voltage, whatever it is. And then this one might need to derive it in a future video.
It's amazing that we can figure out the time it takes for light to reflect using timers that are thousands of times slower than the event we're measuring. So with this time of flight technology, we can map out the room around us just with these laser pulses. But when things get really close, we can't get good resolution because the difference between the emission and reflection of light are so close together. So there are also infrared cameras on board with the infrared lights.
Okay. So now then, when it gets too close, the difference will be even tinier, so they need to use just infrared camera.
Cameras are placed like eyes on the head with slightly different locations. Based on the image location on each of these cameras and the focal length, we can precisely determine how far away something is. The depth of the image is just the focal length times the distance between the two cameras, divided by the disparity between the two images, meaning how shifted they are from each other when you compare the two images. This is how our brain can have depth perception based on the input from both of our eyes. So the robot is literally seeing the room with this method. So combine this with the time of flight, you can have a robot that knows exactly where it is in a room and what's around it. Finally, to make the ultimate vision machine, it has visible light cameras as well. With normal cameras, it can sense different textures and colors and really combine everything to have superhuman vision. But the best thing about the Eufy S1 Pro is that it doesn't store the images that it takes. It simply uses them in real time to navigate its environment. This protects your privacy in your home. I mentioned at the beginning that the Eufy S1 Pro is the first and best floor washing robot.
Okay, let's see what happens.
Since it swapped out this water, that means it's not. And I'm going to shine an ultraviolet light on it as the Eufy S1 Pro mops. Let's see how well it can actually mop up this dye on the floor.
Okay, anyways.
Whoa, that actually did pretty well. It even got in the cracks of the tile.
Okay, yeah, so he's sponsored by that, but then he has another pretty cool one. It's similar to this. Let's go to 3D phone. Yeah, so 3D holograms, unlocking the hidden lasers to make 3D images. And this is pretty cool here.
Hey everyone, today I'm going to be showing you how it's possible to use your smartphone as a 3D scanner to give you complete 3D images of yourself or object.
Yeah, because notice this one has LiDAR on the iPad Pro. Or I think the iPhones have it built in. I'm not sure if some other ones have it as well. So this is 4th generation iPad Pro has a LiDAR scanner on it. See what the lasers here.
Did you know if you have an iPhone 10 or later that your phone actually has lasers in it and it shines out lasers at you to do facial recognition?
Oh, so that's how the facial recognition is. Okay, so it's got lasers shooting into your face.
And actually, if you have an iPhone 12 or later, it actually has little lasers that shine out of the back of your phone as well.
So yeah, so iPhone 12 later shines in the back and front. So you got face and laser beams.
So in order to do facial recognition on your phone, you can't just use a traditional camera because it has to be able to tell the contours of your face to recognize if it's actually your face. So what facial recognition does is it actually sends out a grid of laser light. Now this laser light you can't see because it's infrared lasers, but you can still see these if you just have a security camera that uses night vision. So I'm just going to be using one of the cameras in my house that has night vision, which means it can see infrared light, and you can actually see these grids of laser lights coming out of the phone. So for example,
and also I want to go back to, what was that other video? I want to send that as well. I'll put that in the links, and let's go to LiDAR. Got a comment here. Okay, and also, yeah, speaking of Hurricane Melissa, yeah, so my Melissa 9/11 video is going viral amongst normies. So a bunch of normies commenting, because it is pretty tragic. This story kind of touches both ends, mainstream emotions and and alt media. I mean alt advanced technology. Conspiracy and so on. So it's got everything in there. I'm gonna go quickly summarize. Okay, we got summarized there. I'm gonna go right here and click this as well. This is pretty cool. And now this is the hidden lasers. It's pretty. I didn't realize how ridiculous even just modern phones are.
For example, I'm standing here, you're seeing me through infrared light. It's actually dark in the room and looks more like this. So you can see the screen of my phone here on the regular camera. I'm still here, but it's too dark to see. But on infrared, you can see it just fine. But here's the crazy thing. Watch what happens when I turn on my phone and look at it through facial recognition. Here's what it looks like with regular light, so you don't notice anything.
Actually, infrared picked up some IR as red, that the eye can't see. Okay, so it picked up some infrared as red.
But here's what it looks like through an infrared camera. Turn it on.
Okay, so whenever you get the facial recognition on your phone, it's literally shining a whole bunch of lasers in your face. It's like infrared lasers. It's actually wild.
So you can see that it looks like a flashlight here that I'm aiming at the camera. But what's cool about this is notice the pattern that it's shining on me. It's not just straight light, but it's actually little dots. When I shine it on the wall back there.
Yeah, that's absolutely ridiculous. Okay, that's a bunch of laser dots on your face. Infrared. To measure the contours of your face and so on.
Here's what it looks like through. So you can see this. Notice the pattern.
Okay, this.
And then it's shining.
Okay, I'm gonna take a screenshot of this. This is actually mind-boggling. Hidden lasers. I'll go right here. The action lab. Okay, this is this is quite ridiculous. So whenever you do facial recognition, that's what happens. And I'll post this here. And I'll post where's the other thing? Telegram here. And I'll post the video. I'll close. Yeah, I'll keep those open actually. I'll just go back here. Share and then copy this. Ignoring yes. Anyways, everything after is just a tracking. So the question mark is a tracking. And go back here. I'll do a summarize as well. And it'll still summarize even with the image, which is pretty cool. Okay, and post this here. Yeah, Dr. Das awkward. That's messed up. Yeah. So, anyways, it's when you do facial recognition. That's what it's got. I want to get an infrared camera. I want to be able to see when my phone like laser beams. I don't think I've ever done facial, or maybe I've done it once. Yeah, I don't think I've ever done facial recognition. I just try to avoid anything. Let's see.
Shining on me. It's not just straight light, but it's actually little dots. When I shine it on the wall back there.
No, it's a bunch of laser lights right in your face. Okay.
Then it estimates, and what it does is it shines those laser dots on the user's face, and then it estimates the shape based on how those dots are deformed in the array. Now this is really cool technology, and what it means is that you can actually use facial recognition to scan other 3D objects. And there's different apps that do this. For example, here I'm using an app called Scandy Pro, where I've scanned my son's stuffed animal.
Oh, or really? Okay, yeah. So
you can just scan your face. For example, here's my face. So just in a few seconds, I can get a complete 3D image of my face. You can even export this as an STL file and 3D print your face if you want to.
Okay, Tammy says, I just saw someone post images on the moon with some areas that appear similar to infrared patterns. Interesting. Interesting. All right, Gonzo says, always making pics of you. Yeah. I was making pics of yeah, it is definitely doing this. Again, so there's a picture of himself.
Now the color is added through the camera. If you don't use color, it would look something like this.
Okay, that's that. Oh, the camera adds color. Okay, yeah, okay, so
color is added through the camera. If you don't use color, it would look something like this.
Unbelievable.
But what's even cooler is with the new iPhone 12, they added something that was seemingly untouchable to regular people.
Yeah, LiDAR.
LiDAR. LiDAR works by sending out lasers and seeing how long it takes for the laser light
He's got the Wikipedia image. Let's go.
to be reflected back. And so based on how long it takes the reflection to return, you can tell how far away something is because we know that the speed of light is constant. And if you repeat this process with a 2D grid of lasers, that means you can get a three-dimensional pattern, or a point cloud they call it, of all the different points in space.
Another Wikipedia image.
Any object or room that you're in. So you just shine it around your room and you end up with a 3D image of the room like this. So cool.
Unbelievable. So you can actually go and make a 3D of your entire house.
My favorite thing to do is use this in a room with a mirror, and in your 3D image, it looks like that mirror is actually a portal to another room. So here's what would be the reflection, but you can see it actually looks like another room over there.
Oh, wow. Yeah, so it's a reflection, but then you go around. So what do you say it again?
My favorite thing to do is use this in a room with a mirror, and in your 3D image, it looks like that mirror is actually a portal to another room. So here's what would be the reflection, but you can see it actually looks like another room over there.
Unbelievable. So it reflects off the mirror. LiDAR, infrared reflects off the mirror too. Both a car. Okay.
Now on the back of your phone, if you're using LiDAR, the array is not as fine. There's not as many dots.
Okay, so it's more spread out, but bigger dots, so that again, it's trying to get farther out.
But they can reach further distances. So you can see here's the array. They're a lot brighter. They're not as close together though, so the resolution isn't as good. But what's really cool about this is in a completely dark room, you can scan it using infrared light, so your phone is seeing what's in a completely dark room.
So you can actually use your phone in a completely dark room with no light and then get a whole 3D image of it. And people claim math is relevant. I don't even math runs literally everything. And it's also logic, just logic.
So you can see the contours of the room.
Unbelievable.
That would normally be pitch black to it, but because it's using these infrared laser dots, it can see the contours of the room.
So you can literally see, you can go inside somewhere without a flashlight and see the entire room. So imagine you were like spying on someone. You just pull out your phone, you get the infrared on there, and you literally see the entire 3D space of it like this, with no. Yeah, with no light, with no flashlight. That's absolutely surreal.
So it's almost like I have this infrared camera here.
It's so cool. All right.
Can look around the room.
Okay, now he's doing some other-ish stuff. Okay, let's go back here.
So the lasers on the front of your phone don't use LiDAR, but they're actually looking at the different shapes of the dots and how they deform in the array when you shine it on something.
Okay, so the front doesn't use LiDAR, it uses more but the dot deformation. I think that's on the reflection.
Deform in the dots and how they deform of the dots and shapes of LiDAR, but they're actually looking at the different shapes of the dots and how they deform in the array when you shine it on something that's three-dimensional. But on the back of your phone, they actually use LiDAR technology, which is sensing how long it takes the light to reflect back to it. So because
okay, so they actually use time on the LiDAR on the back sensor, but on the front, what he's saying is they just look at the deformation because you're super close up, so it's going to be too small of a time difference for it to calculate or to detect the time difference. So you're not able to spot that. So what they do is just, if it's deformed, so you have a big nose like here, like mine, so the light's going to go back. When it reflects back, it's going to be a bit distorted. And so they use that to...
Because of this, the one on the front of your phone is more sensitive and can get down to as little as 1 millimeter resolution. Whereas on the back of your phone, it's meant for like big rooms and stuff. And
Wait, 1 millimeter, I think we said 1 millimeter resolution.
Phone is more sensitive and can get down to as little as 1 millimeter resolution.
Wow.
Whereas on the back of your phone, it's meant for like big rooms and stuff.
Okay, Tammy says your Wi-Fi router and street lamps do this 360 24/7. But is it infrared? I just want to see. I want to see if there's some way to look at it. Okay, I'll do that next.
And iPhones even use it to quickly be able to focus the picture faster than just visual cues could do when you're trying to take a picture of something. And so no matter how much light there is in the room, even in low light, the LiDAR still works, and so you can focus the image really well in low light. It used to be that this LiDAR technology was super expensive, and it took tens of thousands of dollars to purchase just one piece of equipment that used one laser spinning in a circle. Now when you hear that your phone has lasers on it, that should bring up a few key questions. I guess the first question would be, how does it not hurt your eyes to shine an infrared laser at yourself? Well, the wavelength of laser light that the phone uses is 1550 nanometers. Well, the nice thing about this 1550 nanometer range is that first, it's invisible to the human eye, so it's not gonna bother you, you're not gonna see these laser lights flying out of your phone. And second is the human eye is actually opaque to 1550 nanometers. So that means that these laser lights aren't going to damage your eye either. The other thing that should
maybe we'll see.
Be amazing to you that there's lasers shining out of your phone is that how can there be so many laser lights shining out of your phone when you've seen a laser before and typically they're pretty big. For example, here's one red laser pointer. You can see how big this is. And you can get these lasers pretty small depending on the different technology. But to have 30,000 lasers shining out of your phone, you need to do something different here. So what the iPhone does on the front of your phone is right on the front, there's an array of vertical cavity surface emitting lasers, abbreviated VCSEL, or pronounced VCSEL. Now, in order to make a laser, you have to have a source of light that you bounce back and forth across mirrors. And because photons actually prefer to be in the same state as neighboring photons, if you bounce them back and forth a lot together, they'll eventually enter the same phase. So you can phase the photons together and it comes out as laser light. But how do you get 30,000 layers to show up on a tiny little sensor on your screen on an iPhone? Well, what you do is you can actually use MEMS technology, the same technology in which we build computer chips. And you can make a top layer and a bottom layer, and these will represent your mirrors that bounce the light back and forth.
Okay, so the mirrors are the Bragg reflectors. Okay, so these Bragg reflectors are just a bunch of mirrors. Metal contact there, and then metal contact and substrate. Lower N-type sent quantum well. Okay, what's going on here?
But what you do is
Tensor geometry and calculus, and it does affect eyes. Cataracts 7 much. Yeah, also the amount you're doing there. And again, this mainstream one, they'll just say everything's fine, just go buy the latest one.
you make the top mirrored surface a little bit less reflective than the bottom one, so that after a lot of bounces, eventually the light's going to escape, and that's the circle of light.
What did he say right here?
Actually use MEMS technology, the same technology in which we build computer chips. And you can make a top layer and a bottom layer, and these will represent your mirrors that bounce the light back and forth. But what you do is you make the top mirrored surface a little bit less reflective than the bottom one, so that after...
Oh, so the top one is more reflective, this one's less, and it kind of comes in. It kind of reminds me of the Orgone accumulator.
a lot of bounces, eventually the light's going to escape, and that's the circle of light that's going to come out as the laser. And you can have these huge arrays of them, and they don't use a lot of power.
Wait, he said, no, I got it wrong. This is the lower one, is the N-type. This is the more reflective one. I go, back there again.
Bounces, eventually the light, after a lot of bounce, so the bottom one, a bit less reflective than the surface, a little bit less reflective than the bottom one. The surface, a lot mirrored. But what you do is you make the top mirrored surface a little bit less reflective than the bottom one.
Okay, so top one less reflective than the bottom. So the bottom is super reflective, so basically forcing it going up.
So that after a lot of bounces, eventually the light's going to escape, and that's the circle of light that's going to...
And that's where it goes up here. But where's the initial one would be here? How do you get the initial setup there?
...going to come out as the laser. And you can have these huge arrays of them, and they don't use a lot of power.
Yeah, look at that. That's amazing. So you get fire up a bunch of these LiDARs on there.
And thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe if you haven't yet.
Okay, so that's quite well. Let's see if we got the summary in here. I think I did it here. Unlocking your phone's hidden lasers. See if it. Okay, that summarizes as well. Exploring the cutting edge of smartphone 3D scanning technology. Okay, and so on. And then I want to see what the thing he called it. We'll Google that. Yeah, so it goes right here. Again, it's on the Hive blockchain now, so we got that. Oh my goodness. Okay, that doesn't work. Can't press back. So the currently Leo threads is a bit wilding. Okay, I just want to go back here. Okay, so nothing's working there. Whoops. Okay, so it is okay. There it is. We're back in. Okay, so we're back in the game. Yeah, so that's pretty absolutely wild. So that's LiDAR face scanning on there. And yeah, yeah. So I want to go back here. What he said about what is it called? I might do a separate one on this. Just see vertical VSCL Fiscal. Let's go to the wiki on this. Jazz vertically cavity surface emitting laser. Okay, let's just see how this works. Vertical. Okay, so what does it even do? I just want to see an animation. Is there an animation of this? Okay, so metal contact, upper Bragg reflector, 30 period. So basically, then this is goes down, down. You want to push it down one way. P and I. Okay, see, there's a video on it. Again, video is worth 1,000 images. Okay, what is visco laser emitting? Diode. Let's see how this works.
Vertically from the surface of a fabricated wafer, and offers many advantages when compared to conventional edge-emitting lasers. Now let's take a comparison.
Top mirror has less than the bottom. Bottom's 99% reflectives and 99. No, it's 99.9 is 9. Where's initial?
Between conventional.
Okay, and laser cavities in the center. Okay, the laser's in the center. That's what they call a quantum well mumbo jumbo. Oxide laser. Basically, you excite atoms or whatever, and it shines laser. And then the thing is, what's a laser? Okay, and it shines over there. And then I'll say laser. What is a laser? Oh, whoops. This is going back here. Laser scan. I'm gonna click on visco here. Vertical cavity emitting laser. Yeah, so that is it basically does that.
The circular light and reflectivity. This layer is made of DBR, which stands for.
And this is super reflective, so it hits this and goes back here. This is less reflective. So basically, the whole idea is vibrating back and forth so that they all go in the same cohesive state, and it fires. And they have a whole bunch of these little tiny setup, and there's the current goes in there. Quantum well, and then you got them whole bunch of magic going on here. Visco better. Integrating two-dimensional array, so you can do a 2D array. There's a 2D array, 1, 2, 3, 4. You get a whole bunch of that, and again, you have like 30,000 or whatever he has there. Seems like a twist on the Casimir plate. Yeah. Again, they're all intertwined. Advanced tech, mainstream tech, all intertwined. It's just one little variable missing, and then you get free energy tech. It's my take on everything. Okay, so that's that visco. And the other thing is, what is an actual laser? That's just a yeah, what is a laser? Laser wiki. So I might do this for a separate one. See how much time we have. But we still have a lot of time. I can keep going on and on. Laser device that emits light through a process of optical amplification used based on a stimulated emission of electromagnetic radiation. So basically, you stimulate. Yeah. So how do you how would you get it? How would you get it? Are released and absorbed from energy levels in atoms. Okay, so basically the whole idea is you energize atoms and molecules, and they launch light, but they need to get them to vibrate back and forth, and or like mirror reflected, so that they all become the same state. Same as thermal or radiation. So basically heat it up. Yeah, but the actual emission is not the result of random thermal process. That the release of a photon is triggered by the nearby passage of another photon. Must be similar in energy and thus wavelength to the one. Yeah, so you would need to basically heat it up. It's basically similar to thermal radiation. Basically heat it up. So let me quickly, how is a laser? Maybe how laser works. I think it's pretty much just vibrating ether. Vibrating. How laser works in theory. See what this says.
To make a laser, all you need to do is give a big collection of atoms enough energy so they're excited and ready to emit light. Once one of them spontaneously emits a photon, it'll stimulate some of the others to do so.
Okay, so once one goes, the other one stimulates.
You get a nice cascade of illumination. But instead of letting all the light escape, it's more powerful to trap it between two mirrors and let it bounce back and forth through the atoms. All that passing light will stimulate them to emit even more light, and as long as you keep on re-exciting the atoms, they're happy to go on emitting light forever. But why do the atoms emit light just because another photon passes by? It's actually pretty simple. Imagine flipping two coins. They can either be in the same state or in different states. But photons aren't like coins. No matter how hard you try, you can't tell one apart from another. So in a photon flipping experiment, that means there's only one way for them to be in different states, but two ways for them to be in the same state. So they're more likely to be in the same state. And in general, this implies that photons always want to be like other photons, to have the same phase, polarization, and go in the same direction. And what's more amazing is that if a solitary photon passes by an excited atom that could emit another photon, there's a good chance it will emit one, because the two photons want to be together, even before the second one exists. So once you have all these friendly photons bouncing around between the mirrors, you can just open up a little hole at the end and let out a blinding stream of coherent light, a laser beam. To see lasers in action, check out this sweet episode of Smarter Every Day, showing a laser you can stick your hand inside. They also have a bunch of other cool science videos.
Well, laser you can stick and burn. This is actually quite wild. It is burning this while holding up.
Showing a laser you can stick your hand inside. They also have a bunch of other cool science videos.
Again, this is like mainstream gatekeeping stuff. But yeah, so again, he says it's pretty simple. It's how does it do that? It's pretty simple. It's like a coin, but it then completely goes non-intuitive. Like when in a world, why are you talking about coins and then coin flip up and down? Why does it want to go on the same like setup? In other words, the actual underlying thing is not shown, which is just ether vibrating. So why it keeps releasing photons all the time when it's excited? Because you're vibrating the ether. Anyways, so in other words, radiation is just ether vibration, and that's I know Dinu. Unbelievable. So just people got wild names. Just call it something easy like MES. Okay, let's go. This is the one. Again, I like this setup here. It's going light. This is the electrogen or whatever, electrons going back and forth, and then vibrating the ether, compression waves. So basically, light. The reason why there's always radiation, and the whole idea is trapping it into one setup here. Instead of just coherent going up and down, you have a whole bunch of stuff, and then when you align them up, you get a laser, but like super like localized. Anyways, so that's pretty well. Yeah, so laser is just exciting atoms, and then using mirrors, and then using a little spot to pop out. That's pretty cool, and so on. So I do like this setup here, actually, the minute other one. Whoops. I'll close this. I'll close this. Close this. Okay, yeah, so I'm pretty much understanding lasers now. So again, this is why I do these Wednesday streams, force myself to do on the technical stuff, just to get fully immersed. Where did it go? Okay, this one right here. I do want to summarize this. Even though the coin flipping one is just completely non-intuitive. Like, why are you talking about a coin for any reason ever? Like, how is a coin and then the state of a photon? What in the world does that even mean? It's just ether vibration and so on. Anyways. Okay, yeah, that's pretty epic. Yeah, Gonzo, yeah, he said before, it's one of the many ways to use smartphones against people. Yeah, definitely. And what I want to see is, because Tammy said, P-type quantum well as a semiconductor heterostructure where a thin layer of semiconductor is sandwiched between two barrier layers and the structure is doped to have excess of moles of holes, MAG carriers. Seems like twisted chasm. Interesting. Yeah, and also the other thing is, guys, John Hutchison is joining the show this Saturday, and we'll talk about Hutchison effect and a whole bunch of other stuff like that. All right. I want to quickly, because you mentioned your Wi-Fi router and Streetlamps do this 365. I'm gonna go and using using sensor to see Wi-Fi. See how do you see it? This antenna can see Wi-Fi. Researchers use Wi-Fi to see through walls. Okay, now we're on another level. Wi-Fi sniffer has sensors for humans. This antenna can see Wi-Fi. Let's see what this is. This is 8 months ago. And this is 9 years ago.
The fantasy of X-ray vision is becoming a reality.
Exactly how people are moving in the space, even if they are then.
The fantasy of X-ray vision is becoming a reality, thanks to researchers at the Massachusetts Institute of Technology. Graduate students have developed software that uses Wi-Fi signals to recognize silhouettes behind walls.
And it turned out that, yeah, we were able to detect that. And then as we discovered that we can detect it, then we started asking even more advanced questions. Can we use it to detect exactly how people are moving in the space, even if they are behind a wall or occluded?
To see movement in real time, a more primitive method is used. A simple red ball tracks this student as he makes his way through the room and takes a seat.
Okay, so this guy walking is being detected by this red ball is sensing where he's going. I think it's and this is at the door.
He makes his way.
I mean, there's the chairs right here, but they said you could use it through the walls too.
Through the room and takes a seat. Elevation data of a tracked object can show when a person has taken a fall.
This is his elevation
Oh,
across
then find an elevation, so you can literally detect him falling.
time. So when he falls, we see that there's a sharp change in elevation, and then we see that his location is on the ground.
Researchers say the technology will help healthcare providers and families keep closer tabs on the young or the elderly.
This is a device
Alright, so it basically detect the family member at all times, or people at all times.
that basically tracks people through wireless signals. It can do so in a variety of ways, from motion to
Oh, and the signal's here. I mean, this is the detector's over here, so it's through the wall.
identifying who a person is based on the shape of their skeleton, as well as measuring their breathing and heart rate.
Can you hold your breath? He inhaled a lot, so it went up, and then it's constant. You see, so which means because she's not holding her breath, and her heart rate is pretty high. I think she had already took off.
They also say the technology
Yeah,
has
heart rate detector too. What's that? Oh, what did it say? Heart rate and breathing. Let's go back.
Shape of their skeleton, as well as measuring their breathing and heart rate.
Breathing and heart rate.
You hold your breath.
So when you hold your breath, and then it shows that your chest.
He inhaled a lot, so it went up, and then it's constant. You see, so which means because she's not holding her breath, and her heart rate is pretty high. I think she had already took off.
They also say the technology has uses for law enforcement as well as the military.
In case of hostage, for example, you don't want to send the police inside without knowing where the people are standing, where the hostages are, if there's somebody with a gun, where they are standing, so that they come prepared.
MIT hopes to bring the healthcare device to market by 2017. Luke Sheridan, The Associated Press.
Okay, so we got Wi-Fi seeing through walls and so on, and then LiDAR literally getting full 3D images of everything anywhere. Yeah, and we're just we're just doing whatever it takes. We're just doing whatever. Okay, and yeah, that's pretty absolutely wild. I'm gonna go summarize this. We got Wi-Fi through, and you can see the breathing and heart rate. Okay, what in the world? And that was 10 years ago. Yeah, this is that's 13 years ago was that laser one. This one is again 9 years ago. Unbelievable. This antenna can see what is.
This ESP32 antenna array can see Wi-Fi signals.
This is an unmodified smartphone that's currently generating Wi-Fi traffic. Now, watch what happens when I take the image generated by the ESP32 antenna array and I overlay it on top of the camera image. Now this phone turns into this glowing green blob.
Okay, so you can detect it, so grow a bunch of Wi-Fi signal.
This is not just a simulation. If I start walking around, you can really see how the ESP32 antenna array can visualize the Wi-Fi signal that this device emits. Metallic walls, like this one here, behave like mirrors for radio signals. You can see the direct line of sight path, but also the reflected path in the mirror. You might also be able to tell that the reflected path has a very slight yellowish tint. This is how I visualize the path delays, and the path delay of the reflected path through the mirror is a bit higher than the direct line of sight path. Especially if I block the direct line of sight path with my hand, or at least attenuate it, you can really see that now you're only receiving the reflected path.
Unbelievable. So you can actually block off the... Wait, is the Wi-Fi coming from this or from somewhere else?
You can really see that with my hand, or at least attenuate it.
Yeah.
You can really see.
So yeah, this is coming in, and then it's and you can see it's reflecting off there, and you can block it. It doesn't show.
See that now you're only receiving the reflected path. Of course, for mirrors, we know that angle of incidence...
Oh, never mind. No, wait, this is reflected off that. I just want to go back what he said, actually. This is quite fast. Let's go back here what he said exactly.
Metallic walls, like this one here, behave like mirrors for radio signals. You can see the direct line of sight path, but also the reflected path in the mirror.
Okay, this one's coming from here and off there, but then if you block this is just blocking the direct line of path.
You might also be able to tell that the reflected path has a very slight yellowish tint. This is how I visualize the path delays, and the path delay of the reflected path through the mirror is a bit higher than the direct line of sight path. Especially if I block the direct line of sight path with my hand, or at least attenuate it, you can really see that now you're only receiving the reflected path.
Oh, so this is receiving much more. That's interesting, but doesn't it go through the hand? So, but this is direct line of sight. I don't know. Yeah, I don't know why it doesn't show.
Of course, for mirrors, we know that angle of incidence is equal to...
Okay, Hutchins effect, LiDAR, laser imaging, epic stuff. Yeah, guys, John Hutchins in the show. And also, John, I'll be visiting you again on the, we changed it to the 17th. So Nancy sent her an email saying, send me a bunch of more cash money. Because I had to cancel the other flight. They only got 50% off the flight back refund. But anyways, that's going to be quite epic. So again, guys, I'll just say hi, John, here. Hi, John. Let's go. Guys, John Hutchins in the show, guys. We got a super duper science man. This is a Wi-Fi antenna array that can see Wi-Fi.
Angle of reflection. So therefore, whether or not you can see the reflection depends on my location. So
and also, John, yeah, so I assume you're still ready for... okay, this guy's messaging there. Where is this? Yeah. Assuming you're still ready for Saturday, I'll be sending the links and so on there. We'll talk about Hutchins effect and a whole bunch of other stuff and see what happens there. And also, this guy's just posting on Odyssey. Following you, love your videos. Cap lying, he's lying. Okay, I don't know what this guy's good job is saying. Anyways, let's play this.
So if I come closer, the reflection first moves a bit, and now you can only see the attenuated.
Okay, so now he sees it through the hands. Okay.
Side path. Whereas here, if I'm standing here in the back, now you can again see both the reflected path and the line of sight path. Non-metallic walls only attenuate the signal, so devices remain visible on the camera image. As I'm entering the room next door, you can clearly see me moving around behind the wall.
Okay, so you can see behind the wall with the Wi-Fi signal. Okay, this is wild. You can see someone behind the wall just walking around.
The software filters packets by MAC address, so you can only see my device, even if...
Oh, so you made it by MAC address, so you can only see it. This is kind of like the people saying with the COVID vax. They got the MAC address.
The Wi-Fi transmitters are nearby.
So you can actually attenuate to one address.
Directional antennas, like this Yagi antenna, focus all of the transmit power into a very narrow beam, so they behave a bit like a flashlight for RF signals. This means that if I point this antenna directly at the ESP32 antenna array,
unbelievable,
you can see how the webcam image becomes totally overexposed. You can also see the signal that this antenna is emitting if I point it at some reflector, like this metal wall here.
So you got a Wi-Fi laser beam.
Here you can also really nicely see the yellowish tint, which is due to the higher path delay. On the other hand, if I take this antenna and point it somewhere else, you can hardly see anything on the Wi-Fi image, and this is because only very little power reaches the ESP32 antenna array from this Yagi antenna. To some degree, the antenna array can also track passive targets, like whatever this is. Reflective materials, like the tinfoil in this scene, produce a bright spot in the image. Non-reflective targets can be seen as shadows in front of previously existing propagation paths. This way, the array can act as a passive radar system by exploiting existing Wi-Fi signals like SSID broadcasts from an access point.
So wait, I don't understand what this was. You can just detect reflecting off stuff. Let's see back here.
The antenna array from this Yagi antenna. To some degree, the antenna array can also track passive targets, like whatever this is. Reflective materials, like the tinfoil in this scene, produce a bright spot in the image. Non-reflective targets can be seen as shadows in front of previously existing propagation paths.
So reflective ones it can detect for some reason.
This way, the array can act as a passive radar system.
I think that's because his Wi-Fi, he has it in his hand. So anyways, so you can literally detect things that are shiny just by sending off Wi-Fi signals.
By exploiting existing Wi-Fi signals like SSID broadcasts from an access point. Outdoors, propagation paths tend to be longer. With 40 MHz of bandwidth in the 2.4 GHz Wi-Fi spectrum, we can achieve some level of depth perception. Path delays are indicated by color, with a varying reflected path length creating this rainbow pattern. Shorter ground reflection paths appear in purple or blue, while the late arriving reflection from the building in the background is shown in red. So how does all of this work? How can we get this kind of information from a cheap Wi-Fi microcontroller like the ESP32 that you can get for less than €1.50?
Let's go back to the scenario with the metal wall from earlier.
This guy's going full in depth. Okay, he's got a 3D model too.
In this somewhat oversimplified explanation, the transmitter is modeled as a point source emitting an electromagnetic wave. When the transmitter sends out the Wi-Fi packet, the ESP32 antenna array first observes a wavefront from the direction of the source, and slightly later, a wavefront coming from the reflector. Depending on the angle the signal is coming from, the individual antennas observe the wave that is moving at the speed of light at slightly different points in time, with a time difference measured in picoseconds. To determine the angle of arrival and to produce an image from the received Wi-Fi signal, we need to synchronize the receiver chains inside the ESP32s precisely. In other words, we need to achieve something called phase coherence. Typically, a relatively inaccurate crystal oscillator serves as the frequency reference for the radio receiver inside the chip. To synchronize multiple ESP32s, we need to provide the same 40 MHz frequency reference to all receivers. This ensures that the local oscillator signals across chips are now frequency synchronous. For phase coherence, we also need to make sure that the local oscillator signals are synchronized in phase. Providing the same frequency reference to all ESP32s is insufficient for that. To understand why, we need to take a closer look at the internal structure of the chip. Here we find something called the PLL that derives the local oscillator signal from the 40 MHz reference. The local oscillator is then used to mix the Wi-Fi signal down to baseband. Let's observe what happens to the output of the PLL as we turn the reference signal off and on again. While the local oscillator signal is always at the correct frequency, we get a random phase offset relative to the 40 MHz reference. This effect is sometimes called phase uncertainty, and it is likely due to the specific kind of PLL used inside the ESP32. To get rid of this offset, we need to add another ESP32 to the system, which provides phase reference packets. These packets travel across microstrip lines on the back of the PCB with well-known length and group velocity. By measuring the phase of the reference packets at each receiver, we can compensate for the phase uncertainty in software. This calibration procedure is only necessary once after each ESP32 has booted up, or in case we switch the Wi-Fi channel. The ESP-IDF Wi-Fi driver documentation lists all steps needed to obtain the so-called channel state information for every incoming packet. Channel state information from a single ESP32 looks like this. We get a...
This is a bit wild. This is a bit more than my knowledge base, but I'm very interested in this technical mumbo jumbo. How are they getting all this?
Phase and an amplitude measurement for every subcarrier inside the Wi-Fi bandwidth. You can see how the curves change if the transmitter starts moving. This is the channel state information from all 8 ESP32s in the antenna array. Each color belongs to a different antenna. By taking the Fourier transform along the subcarrier axis, we obtain the channel impulse response.
Okay, yeah, so Fourier one is one of my favorite math stuff. I got it's been years since I looked at it, but that's pretty cool. You can take a bunch of stuff and make a sine wave.
X-axis can be interpreted as a time axis now, and the Y-axis indicates the amount of power received at different points in time over different propagation paths. We can now apply array processing algorithms to determine the angle of arrival of the incoming signal or to generate the Wi-Fi camera images. With multiple antennas,
this looks like he's doing it for a thesis or something. This is pretty advanced stuff. Research assistant at the Institute of Technical Communications at the University of Stuttgart. Work on multiple antenna system like distributed massive MIMO. Interesting.
Arrays, we can even build an indoor navigation system. Combining the angle of arrival estimates from multiple points of view, we should be able to triangulate the location of the signal source. This animation shows the triangulation results.
Oh yeah, because if you have the angles, all you do, you get the same stuff set up here. Provocation paths. Okay,
a measurement campaign with a transmitter on top of a robot.
If we provide the same clock and phase reference packets to all 4 ESP32 arrays in the system, we can also use time and phase difference of arrival.
Okay, this is a phase, not only time difference is shown here.
Obviously, the best localization accuracy is achieved if we combine both techniques.
Okay, basically, yeah, it's doing triangulation and getting a whole bunch of stuff there.
By supplying a shared clock and phase reference to multiple arrays, as mentioned in the TDOA scenario, we can also combine them into larger arrays. In practice, phase-balanced RF splitters at the back of the antenna array distribute the reference signal, ensuring phase coherence across all antennas in the combined array. Larger arrays offer more accurate angle of arrival estimates and a higher resolution for the Wi-Fi image. One more remark on indoor localization. Triangulation and TDOA-based trilateration assume multiple arrays and the existence of a clear line-of-sight path between transmitter and receiver. But what if there is only a single array and obstacles in the environment? Can this antenna array still determine the transmitter's location on the other side of the metal container? By now, you have seen how radio signals reflect off various surfaces like the floor, the ceiling, and walls. By observing one or more moving transmitters for a while, we can collect a dataset of wireless channel measurements. We can then feed these channel measurements into a neural network using a self-supervised
Okay, so now we got AI, basically feeding it all to a giant AI model.
dimensionality reduction technique called channel charting. Work to a neural
So you get all the data, throw it to AI, and it'll give you the answer.
Dataset of wireless channel measurements. We can then feed these channel measurements into a neural network using a self-supervised dimensionality reduction technique called channel charting. After some neural network training, this method figures out the geometry of the environment. In other words, even a single array can locate transmitters behind corners by observing reflected waves.
They learn positions, true positions like that. Is the learned one is guessing where the thing is.
The resulting map, called the channel chart, is fairly accurate in both line-of-sight and non-line-of-sight areas. Once trained, neural network-based localization is possible in real time.
Okay, estimated, and then the true position.
More information, resources, and channel state information datasets are available on the project website.
And this is wild there. High hint move spacebar. Okay, I gotta get to this website. This is actually spargos.net. Okay, spargos.net. Okay, this is actually wild. This guy's on another level. This would have been an interesting career field. Yeah, this guy's got it all, and amazing setup here. Okay. Where's the? I wanted to I thought he had one there, and I was like 3D. View demo overlay. Oh, there's a view demo on GitHub. The one I wanted to see was this one here. Experiment setup. Okay, where does he get to?
More information, resources, and channel state information datasets are available on the project website.
Okay, this one right here. Where's this website? Point cloud download instructions. Documentation datasets. 4-phase explore. Okay, anyways, yeah, this is yeah. Did this make this with the model? What, like, how does he get this whole setup there? Point cloud download and usage for dataset we provide which is generated using a 3D scanning device. So guys, this is a 3D scanning device. Never mind. Basically, use that phone setup. But that other guy's like iPhone was like better than this quality. Anyways, that's pretty wild stuff. This is actually quite fascinating. Trying to wrap my head around. But again, it's just a bunch of math. FOIA analysis is like literally where it's like magic. It's quite literally you take everything, put it into a sine wave, and now a sine wave you can do anything you want with it. That's pretty much signal analysis, all FOIA. I might do that for a future one. Okay, what is FOIA analysis? Because I need to do a video on it. It's been years since I've done it at university. It was one of my favorite ones. FOIA yeah, analysis wiki. Let's go there. I'll do that for another math one. Okay, anyways, that is that. Go back here, summarize. Okay, summarize that. Yeah, it's pretty wild. And then the website here, Espartago. This guy is on another level. Yeah, definitely. So this guy, yeah, you should get him on the live stream. But first tell him Hudson fact they can literally turn towers and dust. Not just LiDAR. You don't need to just track where everything is. You can actually manipulate and levitate and throw everything around like it's nothing. Okay, so that's that. And this part here. All right. And we have 19 minutes. See what else we had in the show. Okay, yeah, LiDAR scanner. I want to check the iPhone. I mean, not iPhone. Samsung Galaxy S25 specs. I think. Let's see if I have the thingy there. Let's see if there's LiDAR. This is face. Does it have? Okay, interface. No. I'll just ask Rock. Does the Samsung Galaxy S25 have LiDAR or facial recognition lasers? Every location has its own signal which can be graphed through tensor calculus. Yeah, definitely. Tensors, yeah, it's pretty much like generalized math. Put everything into one little thingy there. Oh yeah, and I want to go back to the FOIA. Okay, FOIA analysis, right here. The study of the wave general functions, which maybe, yeah, is the way general functions can be represented or approximated by simpler trigonomic functions. So yeah, basically you turn everything into a trigonomic one. And when you have trigonomic one, you can have oscillations. This is Fourier transform of bass guitar time signal of open string A1 note. This is just a note one right here, and then yeah, that's interesting. You have it set up like that. Because Fourier transformation and 3 variations caused a period of sampling at interval. Transformer periodic sampling, periodic summation. Anyways, discrete Fourier transformation. Spectrum of signal, time domain signal, and then plot of frequency magnitude. Where's that should be a good setup there. Yeah, again, these people don't like the input and output are similar. Just make it something pretty cool. Fourier analysis, powerful, or just amazing. Let's see what just an image of it. What you could do. Okay. What's the animation? So this is time in out. Yeah, so let's say you had the switch on off, and then you can convert that into a giant sine wave. So you can deal with the sine wave as opposed to just this. So you have this input. Let's see, let's visit the site. Fourier transform. I just want to show the whole thing. Why isn't it just showing the entire thing? Like, what's the issue? This thing. Okay, this is pretty cool. So you have this input, and then you basically turn this a bunch of sine waves, and then you get this little thingy there. That's interesting. How did they do that? Frequency domain. Oh, this is frequency domain. So you can turn that into an equation. Like you could turn this up, down, into an equation there, and you just transform that into just a simple equation you can plug it in and modify. I think that's how it is. Let's see what it is. Time. Yeah. Yeah, that's kind of what I mean. Yeah, so if you have a square wave like this, and then you could change it up into any kind of sine wave. Yeah, so you can have if you have an on, off, you can turn it into a sine wave, and so on. So you can turn much, like, very complicated setup there. Okay, signal processing and filtering using discrete Fourier transform. Okay, interesting. You turn a bunch of this into that. Yeah, I'll be doing that maybe for later. Not a Wednesday. The type one requires a bit more info on it, a bit more in depth. All right. So, anyways, that's that. Okay. So no, Galaxy S25 does not have a LiDAR sensor. Yeah, time of flight, depth sensor, any facial recognition sensors, lasers like Apple's ID, Face ID, dot projector, or laser. Okay. So I don't have that. So if you have an iPhone, you got powerful. Okay, which one does it have though? Which? Oh, S25 Ultra uses the same. Okay, so S25 Ultra has it. All right, so mine doesn't have these laser beams from space. Okay, so it doesn't have it. Yeah, this is pretty absolutely amazing. So again, this is. I want to play this quickly. This is again. There's a LiDAR data there. This is trucks again. Judy gave me the insight for the tidbit on making the animation noise and up and down motion. Okay, let's go right here. Let's play. Okay, there's a yeah. So basically, this is 2 scale. It's Titanic, 280 feet, 882 feet. Tammy says I do, but I have the 12 Ultra Plus. Okay, interesting. Show us some laser beams. All right, and now that's again 20 Titanics is not there, and just 2 towers. And then you got the building 7's like 4 Titanics, and you got a whole bunch of other Titanics everywhere. Like the center of building 6 is probably 1 Titanic. Okay, hello, what does that mean? It's on 13 series and up. Oh, 13. I thought he said 12 and up is the other one, and then 10 and up is this the front. Okay, DM me if you want her Telegram contact. Who am I telegramming? Like, what's going on here? Alan has okay, someone's messaging. DM me if you want copies there. View 2 replies. But what am I DM if you want her Telegram? Whose Telegram is he talking about? Okay, whose Telegram am I doing that? Okay, whose Telegram? Was he messaging before? I don't know. Whose Telegram is he talking about? Okay, I don't know who he's talking about. Okay, whose Telegram contact is he wanting? Is he talking about this person here? Maybe get her on the show, maybe. So anyways, yeah, so that's pretty wild stuff there. Okay, let's go back into this here. Okay, 3D printed models. Yeah, anyways, yeah. So again, this is all disappears and it's all gone. You can't make stuff up, and it's literally gone. Like it's just no way ifs, ands, or buts. It's just gone again. Anyways, pretty wild stuff. Okay, let's see what else I had in here. Okay, a comment here. Whoops, why is it open like that? Like, who's doing this? Okay, I think the links are like just. It's like, how trash is it? Can't even open a link there. Okay, so I gotta do that. Just like, what kind of cardboard box we living in? Okay, MES, hello, what is your problem? Hello? What's the question mark? What is your problem? Mabs. MES, hello. What? What problem? You don't remember my name from the chat, meanwhile ignoring me with 8 viewers. Who's Mabs? I don't know, why is he, okay, anyways, I don't have time for this. Go to channel activity. Is he a troll? Are you a troll, or just, who is this guy? Professional gamer, Steam community. I have no idea what's going on here. Yeah, he said hello. Okay, anyways, I don't have time for this. That's crazy, bro. What's going on here? Anyways, put a timeout in the next nonsense comment. You can put a timeout or just delete it. I just don't have time for this. You don't remember my name? No, Mabs? No, I've seen your name before, but I'm just saying, you said hello with a question mark. I don't know what the question mark is. And I said, what's your problem? What problem? And then there's a hello question mark. Like, what's the question mark for? Is it a typo? Like, why you're the one who has a question mark? Like, am I blind? Do you not see that you have a question mark? I donated many times. Yeah, no, great. No, I'm just saying, there's a hello with a question mark. I'm thinking, well, and then you said, what's your problem? And I'm saying, what do you mean, what's the problem? It says a hello with a question mark. You don't remember? I think you may have, yeah. But anyways, I just don't like. Just tell me this. Tell me what's going on. I don't know what's happening. I have to. Okay. Oh, this guy here. Okay, this guy commented earlier. Anyways, apologies if I. No, I do remember who you are. I know not the details. I just know maps. But I just don't know why you're up in my grill. up in my grill for this right here. Hello there. Okay. Oh, this guy says a truther person. Oh, okay. Yeah. Oh, cool. Alan Forrest. Yeah. Okay. Cool. Yeah. Okay. I'll be like, oh, cool. Yeah. Send me it. Alan Forrest. I'll hands out the newspapers. Every week. And knows them. Okay, yeah, I need to know who it was. Mabs. Anyways, Mabs donated many times. Yeah, and I'm just saying the hello question mark. Like, I don't know what the question mark is. What's the question for? Like, I'm really angry at the question mark. It's like, what is it? Why is there a question mark? It shouldn't be with the exclamation mark. Hello. Hello. I'll do this. Hello. Question mark or no, exclamation mark or. You have 8 viewers and can't deal with one of them. Okay. Anyways, I don't know what's going on here. Just calm down. I have 8 viewers. No, I have 9, including Rumble one. And the thing is, you have to realize I literally do these streams for forcing myself to learn. Like whether it's 0 people, it doesn't change much. Anyways, just calm down, Mabs. I tried to type S to the A, and it didn't work. Oh, I tried to type S to the A to the hook. Okay, anyways, Mabs is wrapping now. Yeah, so I'm gonna go message this guy right here. Okay, okay, he's got it. Oh, okay, that's her. Okay, great, thanks. Add the contacts, just whatever, save it. I was testing it. I got banned or not. Testing if I got banned or not. I still don't know how, like, am I speaking English? Like, what language? I was gonna ban you because I can't handle it. I'm like, it's, but it's all right. Edit folder. Oh, Sandhook. Okay, but why? When did you mention? Oh, Sandhook. Yeah. Okay. I'll go to add chats. I'll go to Guy Lapointe. Okay, let's put this in the personal one so it's easier to see. Okay, I'll do this mark unread for later. Okay, so anyways, so Michelle Zek. Okay, all right, anyways, so that's cool. And oh yeah, so anyways, this guy here says, hello, my name is Wakas Ahmed. We have an actual math question here. I'm a final year master student in South Korea. My thesis focus on multi-view object detection and oh, now we're doing okay, what are the odds? This one just popped up. Is about LiDAR and stuff. Object detection and understanding using synthetic data generated in Unity. I am currently working to fully understand the mathematical foundations of 3D to 2D projection in Unity. Specifically, I would like to learn the exact 3-dimensional logic, coordination, transformation, camera projection, and view matrices, and how this is projected into 2D imaging coordinates with Unity's rendering program. I would be very grateful if you could provide some guidance or reference on this topic. All right. Okay, this person here. I got blank, no comment at all. Okay, I'll type it right now. Sandy Hook. Okay, it worked for me. Does it work for you guys? Okay, Sandy Hook. Again, you could type stuff. I don't know what's going on here. Okay, Grok. This guy says, give some helpful info for this email I received. Okay, okay, this guy's South Korea because he's doing some Grok. Again, people, it's like they just don't know they haven't used Grok. I'll be like, hi. Thanks for your email. I have not used Unity before, but I assume you have seen my 3D to 2D projection video. And then if you go to peak, I've had YouTube comments deleted in real time by YouTube NAI. Yeah, that's just the way it is. The way it is. So we gotta get on the Hive blockchain. Okay. If I go to this one, which was infinite sequences and series, I think it was vectors and geometry of space. Laboratory project. I did this one here. And I will open this playlist. This pretty cool playlist. Okay, this is 3D projection. Projecting, and then this is 2D to 3D projection proof. Okay, and then I'll put a link here. Okay, what's this guy talking here? Okay, this content makes Discovery Channel and History Channel look like Barney and Dinosaur. Yeah, definitely. All right, so we got literally, yeah, this is Now of Alchemy. Yeah, one of the best documentary series of all time. Okay, so now that is, I'm gonna click this guy's response to this setup here. Also, okay, what did Nancy say? I think. Okay, she sent me 300. Oh, U.S. cash money. I guess she sent me a bunch of cash money, guys. She's very, very nice. Okay. Drew through editor. Okay. Yeah. Okay, and then see what Grok says. Dear 2D plant. Okay. I'll just send this one. Okay. Okay. I just did a quick ask of Grok AI. For your question, and I think it might be helpful, as I have used it to generate equations and code for me. Let me know if this helps. Okay, anyways, okay, so we have 10 people now. Okay, so Mavs, we have 10 people now. Can't make fun of me for having 8 viewers. We have 10 plus Rumble guy if he's still there. Be 11. So we are taking over the game, and we have this guy here. It might be a bot on Odyssey, but pretty cool. Okay, anyways, and occasionally we have someone. We have one viewer on X. I think I blank, don't come at all. So is my Sunny Hook still there? Where did Sandy Hook? Okay, Sandy Hook's still there. Okay, so that's pretty cool. Okay, this guy sent a message, and then we have this guy here. Okay, this guy here. Okay, this guy just posted something absolutely epic on the thingy here. This guy says, so for some reason, so this video, I have no idea how this video got uploaded. This was 15 hours ago, and I think, and it was uploaded to the wrong one, MES Science. I think I accidentally uploaded this like 2 years ago on 3Speak. But then I uploaded again, but then I think I told him to just cancel it or something, or it didn't work, and now I just uploaded literally now because 3Speak had some issues with it running and so on. So I have no idea why that is. But anyways, it somehow does that, and it's just surreal. I'm gonna go to video sections playlist because I'm pretty sure I already have it uploaded somewhere else. I'm gonna go actually conspiracy, MES conspiracy. Conspiracy. So this guy here. So anyways, I'll go to Jason. Okay, nothing's working on Hive. Like, what's going on here? Like, what is y'all tripping? Well, the thing is, it's not the Hive. It's the node, whatever. These guys are connected to the Hive blockchain. Yeah, so Moonchild. Yeah, so this guy right here, and also I need to find out who this guy. Anyways, I posted this years ago. I'm gonna just have to update this as well. Just update and put this in the image, upload image. Where did it go? LiDAR, video files. I think it's in the occult section. Okay, I missed occult. Trump. I think it's like sections or something. Okay. I'll just click this instead. I thought there was military. No, why did it go? Okay, no, it's MES. MES. What is it? MES. Yeah, it's got to be in the cult one. I thought I uploaded MES occult. It should be in there somewhere. Okay. Oh, this birthday coincidence. Okay, that was Trump general. Again, Trump's got huge. Okay, meta thumbnails. This is the Roswell Moonchild. Scalise birthday, lunar eclipse, Trump born bull. Friday 13th. Okay, so this is one of the most wildest things I've ever seen. Okay, so Moonchild. Okay, we got a guy popping up out of nowhere. For us, yeah. So Moonchild. Let's put the thumbnail there, and then advanced. Yeah. So I accidentally put this in this one here. Yeah. So anyways, so Trump was born on June 14th, 1946. On a on a Friday, okay, June 14th, 1946, right? Keep that in mind. On a blood moon Except the movie series Friday the 13th, supposedly Jason Voorhees, who is the serial killer, was born on Friday the 13th, 1946. June Friday the 13th, 1946. Except the actual calendar has no Friday the 13th. It's actually June 14th. And it's a blood moon. And the original image for Friday the 13th has blood moon, blood moon, blood moon, blood moon, blood moon. This is the trail. This is the poster. Blood moon, Friday the 13th. But it's actually June 14th, 1946, on a blood moon on Trump's birthday. So that's probably one of the most wild stuff ever. And also, Trump has a $100 million penthouse in Manhattan. And in the 8th film is apparently where they said he was born on June 14th, 1946. That was Jason Takes Manhattan. Like, what is going on here? Yeah. And then so Amateur says it is odd, and no doubt Trump related. They are devious and esoteric. I did the geometry of Jason Voorhees, Donald Trump, as well as Donald J. Trump, but saw only one match in reverse reduction between Donald J. Trump and Jason Voorhees. They're both 68 in that cipher. Okay, I want to go to geometry. This is one I like. 6.5 earthquake where those U.S. warships are hanging out and do. Okay, yeah, definitely. That's how it is. Jason Voorhees. Okay, in 966. Okay, that's pretty cool. That's pretty much 666. And then this is Donald Trump. But the thing is, Donald J. Trump is 888. Trump. He's 888, 888, 888. And that's similar to Emmanuel Macron. Emmanuel Macron is 888. Anyways, this interesting thingy. Okay, so. Yeah, this is interesting. And this guy says that bit about June 13th, 1946 being a Thursday flips the whole Jason birthday lore on its head. Friday the 14th lining up with Trump's date and a full moon vibe makes the coincidence extra eerie, almost like the script wrote itself. The Manhattan angle is wild too. Jason and Trump sharing Boro bragging rights made me grin. Yeah, definitely. This guy is taking another level. And now this guy has this emoji. I'm currently making video about Trump and 9/11 and coincidence that I found are even more bizarre. Soon we'll be releasing it to MES conspiracy community. Wow, that's amazing. Looking forward to it. Please tag me into it in case I forget and in case I miss it. Because I'm following this guy. I got him on Hive, and he's actually earned quite a bit now. I'm assuming. P.S. I had posted this video 2 years ago on 3Speak and accidentally posted accidentally posted on MES Science Community. So I requested they remove it. And suddenly, 2 years later, today it was uploaded for some reason. For some strange reason. Yeah. Instead of okay, and also I have the that's MES Science. I also have MES Nano of Truth, but again he can post either or. Should be fine. Okay, yeah. That's pretty wild. Again, this guy here, Gonzo. Oh, yeah, he's got the Trump emojis. You have Trump emojis. How's he doing that? He's got Trump emojis. Unbelievable. Okay, and then he's got the fire, and there's Trump there. Yeah, Trump's a wild man. Again, I still to this day do not know how people could be, how conspiracy peeps can be pro-Trump. It's like doesn't make any utter sense. And also, yeah, I want to check how much money this guy's made. So again, he gets a lot of upvotes from me. So he's probably got a lot of cash monies off me. Yeah, so he has his thing's already $3.91. That's pretty good, but it was pretty good. And he's getting tips and so on. He's getting pretty again, if you imagine, he's been only doing this for like a month or so. September 2025, literally just 1 month. He's got $3. Imagine this for years. You're just gonna get stacks and stacks and stacks of money, and you know, all your thing is just gonna be locked up forever. Like nobody's gonna touch your account. Nobody can change it. And so on. Or anyways, pretty much, I think we're pretty much done. I think there's another thing I wanted to go over here. I think this was Mystic Bazaar was messaging me. Okay, Mr. Bazaar was saying stuff. Uploaded the test respeak. Okay, actually, I'll look at it later. I just don't have time. Yeah, for sure. You can upload my 3D printed. You can upload that video. I was going to film another, but my niece's nephews broke some pieces off of it. So that is the best video that will ever be filmed, ever be filmed already. With this model. Okay, this one here, I'm not going to get mad. Then anyways, tester is just encoding. First time I managed to do it in ages. I've tried embedding my TikTok videos, but it only brings up description. Changed my background to a more 911, so I've been spending time on. It's nearly 10th day. And let's just check if she has it already. Mistake. So again, okay, so she's got posting stuff here. Yeah, Project Blue, and there's an article. So again, look at this. 56 cents. Right now, it just earned me upvoting her stuff. And okay, the video is uploaded. Okay, there's the video. So now that her video is uploaded. Okay, so all right, great. Your 3Speak video is uploaded. You can embed directly 3Speak videos as it is already, as is done automatically here. Also, you can make an article requesting Hive developers or not Hive/Peaked developers to make an embed of TikTok videos too. Okay, yeah, just ask them. Again, Hive is just a database. Everything else is you can do anything you want on it. You can make your own website and do that. Anyways, that's that. And there's last one. There's another comment. This person keep asking me stuff that is a bit beyond my thing. I want a YouTube tutorial on cyclostationary based. Okay, I have no idea what in the world this even means. Cyclostationary, stationarity. Okay. A signal having statistical properties that are that vary cyclically with time. Signal having statistical properties of multiple interstationary processes. For example, the maximum daily temperature in New York City can be modeled as a cyclostationary process. The maximum temperature on July 21 is statistically different from the temperatures on December 20th. However, it is reasonable approximation of the temperature on December 20th of different years as identical statistics. Thus, we can view the random processes composed of daily maximum temperatures as 365 interleaved stationary processes, each of which takes a new value once per year. Okay, that's pretty cool. Okay. Okay, this is all right. Cool. Maybe in the future. Yeah. Again, you have people have to realize I'm not a math professor or anything. I just do it to learn on my own. Similar to I do these videos, even though there's like nobody on. I mean, only like 10 people on. It's still pretty good. I don't say nobody because you guys are worth like thousands of people. Because the thing about this, you guys are in MES, actual bombshell info, as opposed to just the typical loudmouth alt media or mainstream media, just all over the place. Yeah. So anyways, that's it. That's all for today, guys. And hopefully this thing helps the guys start up there again. Grok is just taking over the game. Have a good one, guys. Have to run. Yeah, I'm leaving as well. Okay, have a good one, guys. Yeah, thanks for joining. And have a great day. And yeah. Anyways, great seeing you, Norman. Again, John Hutchinson will be on the show on this Saturday, so that'll be quite a shindig. All right, and I'll be posting on here. Rumble peeps are in love with the fat orange F. Okay, yeah, it's just I don't get it. I don't get it. Again, I actually got woken up by Trump mainly because my normie friends, like when I first woke up, they're all super anti-Trump. I'm like, how are you anti-Trump that fast? I'm like, it takes me like literally weeks and months to gain some actual info, and then it's like, and then they're already in it. I'm like, okay, something's going up, and then I yeah, and then Pizzagate happened, and realized everyone's yeah, pedos everywhere, and then 9/11. I'm like, okay, they're all just giant trolls. Anyways, have a great day. Okay, this guy, good job, lying guy. I don't know what he's talking about. Anyways, have a great day. Okay, have a great day, everybody. I'm ending the stream in 3, 2, 1, and stream. When are you going to John's? 17th to 20th, 22nd. So not on the 10th, on the 17th. So 1 week extra. Anyways, guys, adios and cheers. All right, peace. And